Yellowstone Eruption. Are we doomed? The latest science Yellowstone National Park is famous for its geothermal features like geysers and hot springs. It's also home to the Yellowstone Supervolcano, which has had 3 major eruptions in the past that changed the world. And it might happen again. Here's what we know so far about this potential disaster. First of all, welcome to my channel. I'm here. This channel is all about helping you understand the amazing science that happens all around us. So if you love to learn, make sure you hit that subscribe button. Yellowstone National Park is located mostly in the northwest corner of the U.S. state of Wyoming, with portions extending into Montana and Idaho. Within the park is the world's largest collection of geysers and more than half of all known geothermal features. The most famous geyser is Old Faithful, which erupts every 90 minutes or so and shoots water up to 185 feet or 56 meters into the air. The water comes from below ground where superheated water and steam pools in a giant underground reservoir created by the enormous magma chamber of the Yellowstone Supervolcano. In fact, much of the geothermal activity that you see bubbling and steaming at Yellowstone is powered by heat from that magma chamber. But just how big is this magma chamber? Well, we can actually see it from space. The Yellowstone caldera is a gigantic magma chamber that extends 43 miles or 70 kilometers below the park. But that's just the size of the caldera. The magma chamber itself could be even bigger, measuring 25 by 45 miles or 40 by 70 kilometers. To put that size into context, that's about the size of Los Angeles, and you can clearly see the circular shape of the caldera from space. But what makes it a supervolcano is its depth. Supervolcanoes are not only large in diameter, they're also extremely deep. The magma chamber beneath Yellowstone is about 6 miles or 10 kilometers deep, which is nearly twice as deep as the similarly sized but less voluminous Mount Vesuvius in Italy. So why do we care about the size of this magma chamber? Well, because when it erupts, there's going to be a lot of material to come out of it. Scientists use the volume of material ejected during an eruption to classify different types of volcanic eruptions. A small eruption like the one that produced the Mount St. Helens eruption of 1980 is considered a small eruption. It blasts lava out over a relatively small area and doesn't affect areas too far away. On the other hand, a massive eruption like the 1815 eruption of Mount Tambora in Indonesia is considered an ultra-colossal eruption. That eruption threw so much material into the atmosphere that it caused global cooling for several years afterward. So what size eruption is the Yellowstone supervolcano capable of? Well, based on its size, scientists think that it could produce an eruption that's somewhere between 2,500 and 5,000 cubic miles or 1,000 to 2,000 cubic kilometers in volume, making it an ultra-colossal eruption. That amount of material would cover the entire state of Florida. Now that's a lot of material and a lot of energy, but luckily it doesn't look like we're anywhere close to a super eruption right now. In fact, there are 3 main signs that scientists keep an eye on to determine whether or not an eruption is imminent. The first is seismic activity. Volcanoes typically produce a swarm of earthquakes before they erupt. As magma rises from deep within the earth, it creates pressure which causes the rocks around it to fracture and shift. These earthquakes can range in size from barely being able to detect them to being quite noticeable. For example, in 1985, a series of earthquakes with magnitudes ranging from 2.5 to 4.8 preceded the eruption of Mount Unzen in Japan. Similarly, in 1991, Mount Pinatubo in the Philippines produced a swarm of earthquakes with magnitudes ranging from 1.2 to 3.9 prior to its eruption. At present, the number of earthquakes at Yellowstone remains low, even lower than normal. So no need to worry about an eruption anytime soon based on seismic activity. The second sign to watch for is ground deformation. As magma rises beneath the surface, it can cause the ground above it to bulge. This was observed in 1985 at Mount Unzen and in 1991 at Mount Pinatubo. However, ground deformation can also be caused by factors other than rising magma. For example, it can be caused by the buildup of steam and gases beneath the surface, which was observed in 2014 at Mount Kilimanjaro in Tanzania. In the case of Yellowstone, although the ground does bulge slightly from time to time, that's mostly due to the movement of magma within the magma chamber, which is normal and not something to be concerned about. The third and perhaps most important sign to watch for is changes in the frequency, intensity, or duration of volcanic activity. Eruptions don't necessarily have to get bigger, but if the frequency, intensity, or duration of smaller eruptions increases, it could be an indication that something more is going on. For example, in 2015, Mount Ibu in Indonesia increased the frequency and intensity of its eruptions, which may have been related to the underlying magma chamber refilling. Although Yellowstone does experience periods of heightened activity followed by periods of dormancy, there's no evidence that the frequency, intensity, or duration of these events is increasing, which is good news. Now let's talk about what would happen if it did erupt. During an eruption, the magma would first make its way to the surface through cracks in the Earth's crust. As it approaches the surface, the pressure would start to decrease, which would cause dissolved gases to come out of solution and form gas bubbles. This process is called degassing. The magma would continue to rise until it reached the surface, at which point it would erupt into the atmosphere. The eruption column would consist of hot gas and ash that would shoot high into the atmosphere. Pyroclastic flows, which are fast-moving currents of hot gas and solid material, would also flow down the sides of the volcano. Lava flows would also occur, which would travel outward from the volcano. Now the impact of an eruption would depend on its size. A small eruption would have a relatively limited impact, but a super eruption would have global consequences. Ash and debris would be thrown into the atmosphere, which would block sunlight and cause global cooling. There would also be widespread damage to infrastructure and the environment. So what's the likelihood of this happening? It turns out that the chances of a super eruption occurring in our lifetime are extremely low. In fact, the scientific consensus is that there is about a 1 in 1 million year chance of an eruption of that size occurring in the next 1,000 years. Even if it did erupt though, the damage wouldn't be as bad as you might think. Although there would certainly be some loss of life and property, modern technology and infrastructure would allow us to recover relatively quickly. There's also the possibility that we could mitigate the damage by taking steps such as evacuating the surrounding area and providing food, water, and medical care to those who are affected. That said, the eruption would have significant environmental impacts, including ash and debris covering large swaths of North America and potentially affecting agriculture and air quality for years or even decades. Now, all of this might sound scary, but it's important to remember that the Yellowstone supervolcano has been there for millions of years, and it's not going anywhere. In fact, it's actually quite beautiful and awe-inspiring. And I hope that you get the chance to visit it someday. So, what do you think? Would you visit Yellowstone National Park after hearing about the supervolcano? Let me know your thoughts in the comments below. Thanks for watching. If you enjoyed this video, make sure you hit that thumbs up button and share it with your friends. And don't forget to subscribe so you never miss another one of our videos.